Okay. So in the previous class we have discussed about the acceleration, the concept of acceleration as the change in velocity by time taken. We have seen that velocity of a particle may change under certain consequences, but if the change in velocity occurs at a constant rate such that at a very instant of time the velocity, the change in velocity is same, like every time, every second, 10 meter per second is the change in velocity. 50 meter per second becomes 60 meter per second in 1 second. 60 meter per second becomes 70 meter per second in 1 second. 70 meter per second becomes 80 meter per second in 1 second. This is how the velocity is increasing, but in a regular order, that is 10 meter per second per second. 10 meter per second, as we have seen in the previous example. So that's why the acceleration is supposed to be uniform and it is calculated as 10 meter per second square, or it can be 2 meter per second square as the situation goes. Now after that we have also seen that there is something called retardation. The velocity need not be increasing always. Sometimes velocity decreases with time. So in such cases velocity, the particle's velocity slows down. Ultimately the particle may come to rest, or it may maintain certain constant velocity, whatever may happen. But in such case, the retardation or negative acceleration is represented by a negative value, minus 2 meter per second square, minus 7 meter per second square, minus 3.5 meter per second square, like that it goes. Now we will come to the average acceleration. So in the previous class we have discussed about uniform velocity, instantaneous velocity, average velocity. So after that we have been introduced to acceleration, uniform acceleration, non-uniform acceleration will also be there. We will not go into the details of that. And here is something called average acceleration, which is very much similar to the uniform velocity. What does uniform velocity tells you? In between two journeys, in between two destinations of a journey, the velocities may change irregularly or regularly. If you know the total displacement, if you don't know the details of the journey, only what you can calculate as the average velocity, the total distance between 2 points A and B, and the total time taken. That much you can do to calculate average velocity. So here in average acceleration, suppose there is a particle which starts its journey with the initial velocity u. After some time, we don't know what happens in the midway. It may stop, it may increase its speed, it may go slow, whatever it may happen. At the end, when the journey ends, or at the another final position, the velocity of the particle is v. So from vu to v, the velocity has changed, and in a time t, for this change to occur, the time taken will be t. In such case, we calculate acceleration as v minus u by t, change in velocity divided by time. Sometimes if initial velocity is high, final velocity will be low. In such a case, when it is slowing down. So in such cases, v is small, u is big, the answer will be a negative acceleration. So if u is small, v is bigger, velocity is increasing, in such case acceleration is positive. So this is the concept of average acceleration. Okay. Now in this class we will go further and we will discuss about the graphs, position time graphs, and velocity time graphs, and acceleration time graphs. Position time graphs. This is very important in this chapter, and based on this there is a very big derivation, very important 5 marks derivation, and as well as for NEET exams also, in the perspective of NEET examination also, this is very important. This concept of position time graph is very important. What do you mean by this? We have seen in the high schools that graphs can be plotted between two functions. There are two functions like y and x. Y is a function of x. X is called independent variable. Means without depending upon anything, it will change itself on itself. It changes itself. Okay, independent. X changes like time. See, whether we are sitting, sleeping, dreaming, dancing, or listening, whatever we can do, time simply goes on. If we stop, time will not stop. Time will be going on for its own. It is having independent behavior. So like time changes, like x. Depending upon time, our positions may change. In this time I am here. In the next second I may be here. I may change my position depending upon the time. With respect to time, I can change my position. Means my position depends on time. My position is referred to as earlier he was there, now he is here. So you are referring to the displacement of me in having the elapsed time in my mind. That's why to know the position of a particle, time is very important. A car was there at the point A 1 hour before. The car is now here. Car is now here. That's what you will understand. So there is a displacement happened. To understand displacement, you need time. If you don't know how much time will after, whether time is moving or not, you will not know whether the particle is there or here. That is impossible. To understand anything, time is the variable. So that's why y is equal to f of t, f of x. Or in other words, for this mechanics we will write it as x is equal to f of t. Why? X is a function of time, because time is the independent variable which will change upon itself. X is called a position. Don't forget, this is about mathematical formulation. Now this is for physics. X means position. Position depends upon function. Okay? Depends upon time, sorry. Position depends upon time. Time is the independent variable. Now, what kind of functions do linear functions have? Linear functions, whereas linear velocities are involved. In such cases, suppose consider a function called x is equal to 3t or x is equal to 2t plus 1. Okay, x is equal to 2t plus 1, or we will take the simplest position, the simplest function x is equal to 2t. According to this function, if you plot graph between x and t, make two columns x and t. Based upon the equation x is equal to 2t, just simply plot the graph. Okay. What is x when t is equal to 0? X is also 0. When t is equal to 1, x is equal to 2. And when 2 is equal to 2, 2 2s are x is equal to 4. When t is equal to 3, 3 2s are 6. X is equal to 3, this is 6. X is equal to 4, this is 8. And x is equal to 5, this is 10. And it goes on like this. Now if you plot the graph between x and t, t is taken along x-axis, and x is taken along y-axis. Don't get confused, okay? X is not y and x here. X is called position. Okay, sometimes we refer to it as a d. Sometimes it is also taken as d. Sometimes it is also written as r. R is also called position. For simplicity, in most of the textbooks we use x for position, t for time. That's why. So in such case, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is our x. This is our t. 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, for 1, 0 is 0. For 0, 0. For 1, for t is equal to 1, x is equal to 2. For t is equal to 1, x is equal to 2. Second marking is obtained. And x is equal to 2, the y will be 4. 4. Next, x is equal to 3, y will be, the position will be 6. Okay. T is equal to 4 and x will be 8. T is equal to 5. X is equal to 10. So what you have obtained? You have obtained a straight line. Okay? You have obtained a straight line. You see that x is equal to 2t is just like x is equal to vt. If you compare x is equal to 2t, it is simply written as x is equal to vt, where v is equal to x by t. Position by time. Position by time means what? It is the definition of velocity. So velocity is a constant. That constant is called the ratio of position with the time, or x is equal to vt. X is equal to v into t, where in the place of v there is 2. So velocity of this particle will be 2 meters meter per second. We can represent it. How do you obtain this? X versus t gives you the velocity. You can take anything here. You consider a triangle ABC. Simply calculate the slope ABC. Slope ABC is AB by BC. Slope is nothing but AB by BC. What is AB here? AB is 10 minus 4. 10 minus 4 because A is at 10, B is at 4. Okay, 10 minus 4 divided by BC. Okay, B is at 5 and C is at 2. 10 minus 4 is how much? 6. 5 minus 2 is 3. 3 2s are 6. That's why it is 2. Slope is equal to 2. That is nothing but velocity of the particle which is constant. Velocity of the particle which is constant because this is of the form x is equal to vt where v is a constant. This is exactly following the relationship y is equal to mx plus c. If you take c as the constant, y is equal to mx where m is a constant, x is the independent variable, y is the dependent variable, and if you plot the graph of mx, you will obtain a straight line. So all these things are indicating that if you plot a graph for uniform velocity, if you plot a graph for uniform velocity of a particle, means position acquired by the particle with the time. Suppose this is the readings from a car or readings from a bike, where x is the position covered by the bike at different time intervals. What was the position of the car at 0th time? What was the position of the car at the first second, third second, fourth second, fifth second? And if you plot the readings and you plot the graph, you will get a straight line graph. It means the car is moving with the constant velocity. It is moving with uniform velocity. The graph will show the nature of that particular motion. Okay, so it is very well understood that uniform velocity gives you straight line graph. Uniform velocity gives you straight line graph for what? Position time graph, not for all. If you plot position and time, and if you plot the graph, and if the graph is a straight line, then it represents uniform velocity, and also you must know that the slope represents the value of uniform velocity. The slope represents uniform velocity. But then slope will represent the uniform velocity. Right. Okay. Yes, this is the first insight you must understand. What kind of graph will be obtained for uniform velocity? Constant velocity. If the car, if the bike, if the particle is moving with constant velocity, then its graph will be represented by a straight line. Okay. Now, there are certain variations in this particular kind of graph. Suppose I will write the position of a particle and time graph is written like this. Position time graph of a particle, a car, is given like this. This is what is obtained. It is not starting from the origin like this. It started from something else called phi. It starts with the phi. Okay. This is how the graph is obtained. What is the meaning of this graph? The meaning of this graph is very, very simple. The meaning of this graph is it has initial position. It has got initial position. What do you mean by initial position? For example, x is equal to 3t plus 5. Sorry, 2t plus 5. X is equal to 2t is that graph. Okay, I must follow the same slope. Yes, I must follow the same. Yes, I think. Yes, same slope is to be obtained. Because x is equal to 2t means the same kind of graph must be obtained. Or otherwise, I will do one very clever thing. What I will do is, yes, I will take this graph. I will write the same graph. Okay, here is 4, 3, 2, 1, 0. Okay, yeah. Now you see the same graph. Now it is not only x is equal to 2t, but it is x is equal to 2t plus 5. Why it is 2t plus 5? It is exactly in the form of y is equal to mx plus c. What is c here? C is equal to 5 here. What do you mean by this? This is called y-intercept. C is called y-intercept. What do you mean by y-intercept? In this equation, y is equal to 2t plus 5. Put t is equal to 0. Put t is equal to 0. What will happen? Put t is equal to 0. 0 x is equal to 0 plus 5. That is equal to 5. X is equal to 5. X is equal to 5 and t is equal to 0. Means if you plot the graph of x versus t, when t is equal to 0, x is not 0 but x is equal to 5. When t is equal to 1, when t is equal to 1, 2 into 1 plus 5 is 6. When x is equal to 2, when x is equal to 2, or means when t is equal to 2, x will be how much? 2 2s are 4 plus 5, 9. When t is equal to 3, 3 2s are 6 plus 5, 11. Now if you plot the graph for 5, 6, 9, 11, 1, 2, 3, you will get the same graph. But the graph starts from 5. The origin is shifted to 5. Means the starting point at t is equal to 0, when time is at 0, when time is not started, the particle already started from the initial position. Means in running race, this is the starting point. A runner will start from the starting point at t is equal to 0. Another runner is there. Another runner is there. He starts his journey 5 meters away from the origin at t is equal to 0. He has initial position. He has 0 origin position. He has initial position. That's why this represents, this kind of graph represents uniform straight line only. If you take the graph, if you take the slope, again you will get 2 only, because in the equation mx plus c, mx plus c, in the place of m there is velocity v, that is 2 only. But c is the initial position. It represents the initial position from which it is moving. Okay, this kind of graph means it has got initial position. This is the nature of position time graph. Velocity is constant. What is the meaning of, now you tell me, what is the meaning of this particular position time graph? What is the meaning of this graph? This is also a straight line graph. This is also a straight line graph. This means particle is moving with constant velocity, which is equal to its slope, and by the equation or by the slope calculation you will calculate that x is equal to 2, m is equal to 2, means velocity is equal to 2. That's all okay. It is a uniform velocity position situation. But this is also a graph, straight line graph, but this is a horizontal graph which is parallel to the time axis. What is the meaning of this? The meaning is very clear. At t is equal to 0, the position is says 20 meters. At t is equal to 0, 20 meters. At t is equal to 1 second, 20 meters. At t is equal to 2, 20 meters. At 3, 20 meters. At 4, 20 meters. At 5, 20 meters. It means what? At all the time, the particle is in the same 20 meters only. Okay, suppose from the edge of the board, I am here 20 meters. From the edge of the board, I am at 20 meters. 1 second, I am here 20 meters. Next second, I am here only. Third second, I am here only. Fourth second, I am here only. Fifth second, I am here only. Means what? My position is not changing. My position is not changing. It means I am at rest. So, particle is at rest. That is the meaning of this kind of graph. How to read the graphs? This is how to read the graphs. Okay? This graph is telling you a story of a stationary object. The object is not moving. How do you represent it in a graph? You will write it in kind of graph. If you understand this, you will come to know the particle is not moving. There is no velocity here. Okay? Right. Particle is at rest. Now, what will be the meaning of this kind of graph? Now, you tell me. You must tell me. Position time graph. Okay? The particle starts from 10 and it will stop there at some 8 seconds. What is the meaning of this? What is the meaning of this graph? What is the meaning of that graph? In that graph, from the origin, particle is moving away because after 8 seconds, say, after 8 seconds, particle is at some 100 meters or something else. It is moving away. After 8 seconds, it has moved away from the origin. It is moving away from the origin, the particle. This particle is, at when time starts, it is already in 10 meters. When time is 1 second, it comes down to 9 meters. When time is 3 seconds, it comes down to 7 meters. In the same way, when time is at 8 seconds, the particle comes back to x is equal to 0. Means the particle is coming towards me with constant velocity. Coming towards me with constant velocity. Remember this. That is how it is. Means at 8 seconds, at t is equal to 8 seconds, the particle comes to the origin. Does not come to rest. Don't think that it comes to rest and stops. No, it's not happening. The particle comes to the position origin. For that graph, the particle is moving away from the origin. Here with constant velocity. Here the particle is coming towards the origin. With constant velocity, and if you calculate the slope, that slope will be 2 meter per second only. Okay, like that. So with what velocity it is coming towards the origin? If you want to calculate, just simply calculate the slope. Slope will come out to be negative. Slope will be negative. Means what? If you go away from the origin to the right side, the velocity is positive. If you come towards the position, towards the origin, towards the left side, you must get a negative number. That's why the slope will be negative 5. Okay. Now I will write another graph for you. Another graph. What is that kind of graph? See, there is a motion which is of this kind. This is x, this is time. You think this kind of graph is possible? What does it indicate? Time is -1, -2, -3, -4, -5. Here in the x-axis you are plotting time. At the 0th second the position is at 0. At the -1th second means time always goes forward. 0th second, 1 second, 2 second, 3 second, 4 second, 5 second. Time always goes in the forward direction. It will never go back. Now my age is 40. In the next 1 year, I will become 41 years. I will not go backwards. My age will not be 39 years. We cannot go to our childhoods. We cannot go to the back time. Time never flows backwards. That's why you know that fact. If you write the graph in which time is taken along negative axis, this graph is meaningless. Physically meaningless. It is not possible. Physically meaningless graph. It has no value. It has no meaning in physics. Because you cannot imagine time going back in ordinary circumstances.